Welcome, everyone. We're trying out something new by holding the Stellar Protocol meeting here on the Stellar stage in the Stellar Dev Discord. We've been experimenting a bit with platforms. The goal is to try to have these meetings in public so that people can see what's going on and can ask questions and can understand the thought process behind changes to the Stellar Protocol. But we also want to make sure that the platform is not buggy, that it works, that it's easy to reproduce the meetings, and that it's easy to attend them. And so we're hoping that this works. We've tried a few different things. If this doesn't work, we'll keep trying things until we get the right fit. But we'll see what happens today. So bear with us. I will say that these meetings, the Stellar Protocol meetings, are designed so that we can discuss upcoming changes to upcoming versions of the Stellar Protocol in order to advance the protocol to meet ecosystem needs. And so a lot of the times what we discuss are CAPs, core advancement proposals. This is where sort of new features that we're going to add to Stellar, or big changes to the Stellar Protocol, start, right? And they are essentially technical specs that outline changes that we plan to make to the Stellar Protocol. And anyone can read these CAPs. They're in a public GitHub repo. The discussion for these CAPs happens on a public mailing list, and some of it also here in the Stellar Dev Discord. Again, if anyone is interested in this process or in understanding the CAPs, or in leaving feedback about them or asking questions, we encourage you to do so. And in fact, if you're going to follow along with this meeting, it's a very technical meeting, so I would suggest taking a look at the CAPs in question. At the moment, we're focused on Project Jump Cannon, which will bring smart contracts to Stellar. And there are actually, we've sort of modularized our approach to this. We're taking different segments of the engineering work that needs to be done to make changes to the protocol to allow for smart contracts, and created a series of CAPs, each of which sort of addresses a specific portion of that work. And so at the moment, there are actually 5 CAPs that relate to smart contracts: CAP 46, 47, 48, 49, and now 50. And over the past week, there have been some changes to CAP 46 and 47, and CAP 50 is a new CAP. Today, we're going to start to continue the discussion about these things. And, as part of that, we certainly, again, encourage you to take a look at the CAPs, encourage you to take a look at the mailing list. And we, in these meetings, try to address some questions synchronously that are important to discuss together. But a lot of the work also happens asynchronously. So I encourage everyone to follow along with that. And so today, it's a fairly open-ended meeting. And I think, I don't know, I'm not even sure the exact best place to start. I know that there may be some stuff to discuss on CAP 47. I don't know if we're ready to discuss CAP 50 yet, or if we still have open questions about CAP 48 and CAP 49. So I guess the first question I have, I guess Lee is not here. I know that there were a few questions about CAP 46, but it looks like Sid, you may have addressed those questions.
Maybe we can get a quick review by John over CAP 50 and the latest changes made there.
Perfect. Thank you. Let's do that. John.
Great. We can open up there, although I do think we probably should go back and talk about 47 with Siddharth later. I don't think we've actually spoken about it much in any of these meetings, but let's start with some overview of what's going on 50. So CAP 50 is, if you saw the first draft that came out, I don't know, about a week ago, maybe a little more than a week ago, it was really focused on just like the question of like, what does it mean to sign smart contract transactions on Stellar? The scope of it over the course of the week, as I thought about it and talked to people, a lot of times, really changed from just like, what does it mean to sign, but more of what does it mean to do, and what is the ownership model that we think should be like the default, basically, of owning it, like basically like, what does it mean to take an action where your action affects some assets that you probably own. And so basically, like, in terms of what's in CAP 50 and what has changed in the most recent edition, basically it opens up with let me actually look at it while I'm talking about it. It opens up with some comparisons against like why the model that is used in Ethereum is really effective. The model being basically like, you can take actions in general if you're message.sender in Ethereum. There are some exceptions, where you use signed messages and stuff, but ERC20 tokens, for example, like kind of a bedrock aspect of Ethereum, are based on this notion of like, if you are message.sender, you control the assets and you can do whatever you want. If you need to delegate that control, you use transfer from, which works via an approval message where first you were message.sender to commit that approval. So this is the same kind of model that I then propagate to Stellar. And so we introduce some new types of transactions, basically, which I'm talking about here is like an invoke contract transaction. This transaction starts off looking just like a classic Stellar transaction, source account, sequence number, fee, all the stuff you're expecting to see. Then the next set of parameters are basically like, what contract do you want to interact with? What symbol are you looking up? What parameters are you going to pass to that function that corresponds to that symbol if it exists? And then a read-write set, which I don't talk about at all and has nothing to do with this cap and is really more to do with cap 46. I'm not going to talk about it. Then the next thing it introduces like, okay, well, like who is running this transaction? Like when I ask who is message.sender, or the terms I'm using is like this get invoker function, host function. What is it going to return when I run that contract? And so basically there's a new signature slot that basically identifies that that person, that key. And then there's one more layer outside of that, which has your normal Stellar decorated signatures. And there's a ton of justification about like why this is a good model, why certain things are done like this. Like why do you have this like 3 deep nesting of structure and all this other stuff? Why shouldn't you, just do signature verification in every contract? Why shouldn't you do replay prevention in every contract? All this stuff kind of ties into it, but that's kind of what's in here.
So, John, one thing that strikes me here is that it's a fundamental shift from the current Stellar account model, in the sense that it doesn't have all the kind of like the high level stuff that you get in a Stellar account. It really boils down to like a single signer account, right?
Yeah, exactly. And I think there's like a lot of merit to this model, mostly because like one of the things you get from like having a Stellar account is this like ability to have multiple signers. But like in reality, we use like ED25519, and you can do a threshold scheme for that anyway. So like you can just sign with a single signature on chain that is like produced via multi-party computation off chain to get a lot of the same results as having an account with multiple signers. The other things that are on the account, there is like when you're running a smart contract, you don't have access the way that I'm proposing, that we've been talking about things right now. You don't really have access to like your native balance, your native trust line directly. So there's no need to have an account to store that balance. Instead, you would potentially do like a cap 49 wrapped XLM type of thing. You don't like, you can use a different account sequence number. You don't need, like, if you want to have a sequence number, you with the same key you can, but you don't need to. So basically this is just like a strictly more flexible model that's going to be more efficient on chain because everything boils down to a single signature. That's my stance, at least.
Yeah, it's worth mentioning that even if you use threshold signatures, if you want to rotate keys, you still need to modify the key, which is basically not an option here.
That is sort of true. There are 2 ways you could do threshold signatures. I'm like not an expert on cryptography, but like if you want to rotate the underlying key, like for example, if your like underlying secret key was compromised, then yeah, you definitely don't have that option here. But if you just want to rotate the key shares, that's actually possible in a redeal, in like in a threshold system that supports redealing. So it depends what level of security you're looking for here.
Interesting. And what's the relationship between the classic Stellar accounts and these new Jump Cannon accounts?
None whatsoever. Like you might have an account that's like GABC, and you might want to sign for your smart contract interactions as like GTomer, assuming that you actually had the secret key for that, vanity key. basically, like, in terms of running, like, in terms of becoming the invoker, the message.sender, you don't need a stellar account to exist for that purpose. It's totally, completely logically separate, I guess. As long as you control the key, you can become message.sender.
I think the distinction is not that jump cannon, there are jump cannon accounts and there are stellar accounts. I think the distinction is that there are stellar accounts and jump cannon doesn't actually have accounts. Jump cannon just has signers or signatures.
That's a really
keys.
good way of putting it, Lee.
Well, you still have a concept of an account on the jump cannon side, but it's more of an like it's like an emergent behavior thing, right? It's like the sum of everything that this signer owns in different contracts becomes the account. It's like an abstracted stuff.
Yeah, I mean, you could describe it like that, but like
think
there's no physical representation.
Yeah, I think there's like what the protocol defines, and the protocol doesn't actually define an account in the Cap 50 proposal. So I mean, the ecosystem and tooling can all refer to these things as accounts. They can treat them like accounts. They can display them in that way, but the protocol doesn't actually enforce that like it does today.
In principle, if everybody hated this get invoker mechanism, even though it's like it's exactly parallel to the message.sender mechanism in Ethereum, but suppose that everybody in the Stellar ecosystem totally hated it. The proposal actually describes how you could just completely ignore it and like everything would work because that's one thing I should point out. Compared to the earlier version that you and I have discussed, Tomer, this version actually makes the invoker signature optional, which was something that came up when I was talking to Nico about like there are lots of times when you just like don't need an invoker signature, like the contract will never ask who the invoker is because it's not relevant, and the invoker signature in ED 25519 where you need to reveal the key also ends up being like 96 bytes, and you just like why sign with some random key for no reason? You could just do nothing. So if people don't like this mechanism, ignore it.
I'm still trying to wrap my head around the interaction between, like, from the user perspective, they have like an account on the Stellar side. And like what happens when they move, let's say we're in a world of Cap 49, not that I'm suggesting we should do that. Let's say we're there. And I move an asset to the smart side. And let's say that my classic side has some sort of like a multi-sig baked multi-sig scheme. Like what would be like the behavior here, the expected behavior?
That's a really good question. I think it depends on what the wallet kind of wants to do. For me, the kind of sane thing to do would basically be to, let's say this is the first time you're interacting with Smart, the wallet generates a new key for you, or it asks you if you want to use some key that you have. But probably it should just generate a new key for you. And then like somewhere in this proposal, there's like a lot of stuff here now. 1 sec. In the like compatible with Cap 49 section wrap, it basically, what you end up doing is you end up signing with the whole multi-sig configuration on Classic that you need. You run this wrap, and it'll be at the medium threshold, I should say. You run this wrap operation. It wraps it up into a smart asset in the Cap 49 sense, and it sends it to that address, whatever address you specify. Now that's the address that owns it on the smart side.
So I'm expected to migrate to a new account ID.
If you don't have multi-sig set up, you don't need to. If you do have multi-sig set up and you uniquely control the key, you don't need to. Like, for example, like imagine that I have like, 3 hardware wallets, and I need 2 out of 3 of them to sign to do anything on my account. Well, it's perfectly fine for me to use the master key. I'm the only one who knows it. But like, if I'm not the only one who knows the master key, then that's not going to work. So it really depends a lot on the configuration of your account. But you shouldn't
we
assume
propose a
that
new
your smart address is going to be the same. No.
do we propose a new stir key for the jump cannon side for these account IDs?
I don't know. That's a good question, Tomer. Maybe we should, yeah.
I mean,
The
you
one
will
thing
need,
that
yeah, you will need that anyways for, yeah, if you want to deposit into contracts.
So I think the dangerous thing here is that I have an account on the classic side. It's a G account. It's multi-sig, and let's say that the master signer is nullified. And now I ask someone to send over an asset on the smart side. They use that like the public account ID, and now I don't have that. And so I'm screwed.
Indeed, if that happens, you are completely screwed.
Sounds like a pretty big foot gun.
I mean, in general, on smart, and this is not unique to Stellar. This is like true on Ethereum with the RC20s too. If you send money to the wrong address, bye money. Like, it's not like Stellar where we're just like, oh, that account doesn't exist. Sorry. So
Yeah, but if the wrong address is the right address on Classic, that's
Ye-
problematic.
Yeah, that's the big problem. The fact that there are like two domains and you have like these addresses that are valid in both domains but actually mean different things. That's like a huge foot gun. So I do think that if we're going down this route, I would definitely say that we need a new stir key for accounts on Jump Cannon.
Well, or a new type of account on Classic, right? That people should create deterministic accounts on Classic that don't have a master signer, so you can't accidentally use the master signer. But yeah, having a different stir key, I guess, would mostly do the same thing.
Huh. That's actually not a terrible idea.
it just seems kind of wasteful to me to require a classic manifestation of an account to do stuff on smart. Like, there's actually no dependence on that thing having any physical manifestation. So like requiring it to come from a deterministic account just seems like super unnecessarily like a lot of
No, I'm just saying, like, then you can't interpret a deterministic account as a because like a deterministic account would have a different stir key, right? And so people kind of moved over to that. I mean, I guess the question is the plan to kind of like completely junk Classic and get rid of it, or is a plan that, like, Classic will form the basis of like a super low cost, like high performance DEX and payment network, right? So in the latter case, it seems worth it to like say that because these smart contracts are designed to interoperate with Classic, we should like make use of the, we should have like a single sign on, if you will, for both sides of the network. But if the plan is eventually to deprecate Classic, then maybe it makes sense not to have single sign-on.
I mean, like, single sign-on is a myth no matter what in the world of smart contracts. What if I just build a smart contract that doesn't use the same scheme? Like, what if I wrote a smart contract that actually just does the same thing as the current get invoker scheme? It does it by, you submit a single signature, I validate that signature, and that's that.
Yeah, I mean, of course you can implement crypto schemes that aren't even supported in Classic or whatever. You can do anything. It's a smart contract. But the question is, what are we going to make like super easy, and what are the idioms that we're going to kind of train our developers to use effectively?
Yeah, John, I definitely agree with David here, because if you look at both Cap 50 and Cap 49, there is, they kind of imply that, we expect everything to kind of like move to the smart side. In reality, if we want them to coexist, then, Cap 49, Cap 50 are, I would say, simple from a protocol perspective, but they introduce downstream complexities across the ecosystem. of having, you know, two types of accounts and two types of balances. So the question is, you know, does it actually make sense if we do think that they'll coexist? You know, what David proposes, like for like having this like another new account that you can migrate to. It's a minimal, it's a different type of account. It's a single signer account, but it actually has representation on both sides. That might be, you know, something that's worth considering if we expect Classic and Jump Cannon to coexist.
Yeah, I also just want to jump on that and just emphasize this, you know, that two sets of keys, that two sets of accounts. I think we have to evaluate this in the context of the goal of equitable access. So this is like all of this complexity for users is maybe easy for someone who is immersed in the crypto, like in the blockchain space. But for your average user who isn't immersed in blockchain technology, that's a pretty high bar of complexity to navigate.
Yeah, and it's not just the absolute complexity, but kind of the shape of the curve leading there. Like in an ideal world, the sort of the there's kind of a smooth line of like the amount of expressivity you gain versus like your expertise, right? And so like if you start just using Classic and you want to write your first smart contract, it's actually there's like a relatively gentle on ramp to get you doing that, right? Versus okay, now create a new account type and whatever, and I don't know.
What I don't understand is David's proposal doesn't eliminate the need for having two sets of keys. Like you just end up with like, okay, like now I have a Classic account, a normal one, a G account, I'll call it. In the terminology we were using an eternity ago when we were talking about deterministic accounts. And now I'm going to create another account that's a D account that has a different key, and I'm right back where I was.
So
I don't.
my interpretation of David's proposal is not to maintain these in parallel, but you know, you get an option to migrate to this new account type, you know, D account. This D account is a single signer account that's valid on both sides, and from that point on, the user doesn't actually interact with the G account anymore. Like they have like this one-time migration.
And presumably new accounts are this D type. But by the way, I don't actually think this is necessarily better, right? Like I think that our, you know, maybe the concept of just like, you know, account authorities is something that makes sense to just kind of expose in the smart contract world, right? And say like, well, these aren't smart contracts in a void. They're smart contracts intended to interoperate with the legacy Stellar accounts, and so to just kind of like expose that the way, you know, we expose single sign-on across multiple services is a useful thing.
Is there like what's the driving force for like why we can't have this key signature be the decorated signatures we have today, and instead of having the source account be message.sender? So like the classic account ID being message.sender, which means contracts still are only dealing with a single identifier. Like, you know, they're dealing with account ID or contract ID as the message.sender. And then the protocol just hiding the fact that, you know, for the most of the time, that's going to be the master key. But sometimes that might be a multi-sig key, but contracts don't actually get exposed to that. So from the Jump Cannon side, it's the same experience. It's an account ID or it's a contract ID, and that's it. Like I think if I understand correctly, the thing we were going for with key signatures is that accounts don't have to exist. And then we just say that an account ID doesn't have to actually exist on the classic side for it to be usable on the... Well, I guess it does, doesn't it? Okay, sorry.
No, it doesn't. Like it's actually the same in Classic, right? Like you don't have, the account doesn't need to exist to use it. Like you can, if it's a single key, like, you know, like you can always reference it and use it in different schemes. Like, you know, as a signer, for example, it's just a key.
So I'd intended to write about this before this meeting today. There wasn't enough time. It's on my list of things to talk about, like why it should work this way and not be just the account signers signing for it. But at the end of the day, my justification just comes back to pre-signed messages all the time for this, which is that if we don't expose what the account signers are, what does it mean to have a pre-signed message? Let me give you an example. Imagine that you're writing an ERC20 token, which is all my examples nowadays because it's like super fundamental token that we're all familiar with. You have these operations, you have balance of and allowance and approve and transfer from and blah, 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 blah. And in this model, everything still works based off of message.sender. So now what I do is I sign with my account. Let's say that I have a 2 out of 3 multi-sig account, like I was talking about before, with I own 3 hardware wallets. I sign with 2 of them. That's how I do stuff. The account only gets message.sender, which is my source account in this model. Okay, but now I want to implement EIP 2612 permit. How do I do that? Like, how would you even define? How would I even define EIP 2612 permit? Also, I'm seeing people complaining about my mic volume.
You sound great.
Hear me well or no?
Yeah, I can hear you great.
Okay, David, then you should just adjust your just my volume for you.
Yeah, everyone sounds good. It's just some people are much, much louder than others, so I have to like constantly adjust my volume, which is annoying. But
if you right-click on me, you can adjust my volume to you. Anyway.
Oh, wow.
Oh, awesome! Thank you.
Yeah, I got you. So how would you even do EIP 2612 permit? Like the way that works is it works based off of signing a message for the public key that was message.sender.
Okay.
So basically, and like what signatures do I use now? Like, do I use the account signatures? Then it's not transparent. I have to go and actually look up the account, find its signature, find its signers, check them against that, blah, 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 blah. Or do I just use the single signature for the public key, which is the very much more computationally efficient thing to do? But it would be wrong. It wouldn't convey the right access controls.
Can we maybe I think there are like 2 problems that we are trying to deal with here. There's one around, I think this one exists even in the current version of CAP50, like regardless. That is, when I give somebody my address, right, like my public address, how does it look like if I decide to upgrade my account? When I say upgrade, to my account to a smart wallet. Like I really want to move all my balances and stuff right under my wallet. So how would that look like? I don't think the current proposal kind of allows you to deal with this type of situation. And then for the signature scheme, like why not? So right now we have keyed signature. Now that it's actually inside, I think what we can do is actually add a new case that would be like classic scheme or something, right? That is just account ID and then threshold, and then the decorated signatures, and that's it. And then you can actually use the invoker can be a classic account ID, which means you can actually use that as as a recipient for anything really. And then you have the threshold, like you do on Classic.
Great, but then right back to the EIP 2612 permit, like you still have to go and act like if I'm a contract implementing EIP 2612 permit, I have to actually go and read the account, look at all the signers, check the signatures.
No, you wouldn't do that. Because you never sign, like to sign something, right? When you sign a payload, the statement that you have is, here's a binary blob, right? That you want to sign as a specific invoker, right? And then here the signature is like basically you have to sign a statement that says those signatures, when you add them to when you evaluate them in the context of this account, you reach this threshold. You cannot guarantee that.
I don't understand how the account could not go and could avoid going and checking. No,
When-
sorry,
when
not
it-
how the contract could avoid going and checking. I don't see how that.
Yeah. Well, it's the same. You mean verification-wise? Is that what you're
Yeah.
asking? That code is that would be we need a function of sorts that is verify, right? That is supports the classic scheme. I think that's kind of all there is to it.
But that has quadratic complexity.
Yeah, that's okay.
It's really not.
No, it's all
if we're
about gas
doing this to
costs.
try to be
Why is
cheap, it's really not.
No, it's gas costs, right? If people want to do that, they are not blocked from doing it.
But it's really, really expensive. Whereas just checking a single signature.
I'm not saying to remove the single signature. I'm saying that you have a way out of the my public address is G whatever, and I don't. If somebody sees my public address and decides to send me funds using Smart, I want that to not go to the dev null. Right?
So then you want the contract implementer to go and implement both verification methods.
I mean, the thing is, we could also have like a parameter type or something like a assigned blob or an account authenticated blob that would be it would be checked independent before executing the contract. Basically, maybe we don't need to verify dynamic data. All the signatures can be checked statically.
We're getting into the area of being super parental and telling people how to write their contracts when, as a matter of fact, they already have, especially things like the type of bridging applications that need this type of capability. They already have implementations on other networks. We don't want to be too parental. I think I'm on John's side with regards to keeping simplicity as a core value and really zooming in on these single signer accounts. But I'm really concerned about the interoperability aspect, for the ecosystem. And I do think that migrating to some sort of a new account that is a single signer, simple account, that you can only migrate to, if you have a single signer or a current account, but having that being existing on both sides is something that the ecosystem can tolerate.
It's a little bit more complicated than that, Tomer. It's not just that you can only migrate if you have a single signer. It's that you can only migrate if the only signer is the master key. And that means lots of accounts will be locked out.
Yeah, so what I see is, your wallet can, obviously there's a migration thing, and your wallet can tell you, hey, if you want to work on Smart, you need to migrate to this new account. Most accounts, by the way, are just single signers, and they do have 100% of the master weight. So I don't actually think that's a problem. But your wallet can tell you, hey, this is this is the new type of account. If you still want to maintain your multi-sig, these are other ways. You can do multi-sig in this brand new world. But the thing is that migration happens once, right? I don't have to actually, as a user or as a wallet developer, I don't need to think about this every time I move between sides.
Yeah, I think it makes it pretty difficult for wallets either today or that are developing for standards like SEP30, for example, to be able to then also interact with this world. We're still sending people down this track of you need to have 2 sets of keys, because the migration path is not particularly clear, I think, otherwise. Or we're saying you have to migrate all the way to this only jump cannon construct. How would you have multi-sig on jump cannon and multi-sig off on classic at the same time with the same account? Is that doable?
So
Would you
I'm proposing like not to actually ever like having just a single migration, and then you're in this other world, which is both classic and jump cannon, but it's on a simplified account model. Now, if you have a multi-sig account on right now on Stellar, then we can think about ways to either, um, you know, either do threshold signatures or just actually deploy a multi-sig contract the same way that multi-sig contracts are on Ethereum and other ecosystems.
what you're describing is every account that exists on the network today that uses multisig deploying their own contract on Jump Cannon.
That is one option. Again, that's only if you want to interact with Jump Cannon, right? So if you're a Vibrant user and you don't, you're not using any smart contract, like these are not things that we need to have figured out like the first, like at launch. And yeah, it doesn't have to be like one contract per wallet, right? It can be, obviously, the Parity wallet is not a great example, but the Parity wallet was like a single contract that provided multi-sig for a lot of accounts, right?
I hear that wallet's super secure. In fact, nobody's ever been able to get their money out of it.
Yes, it is super secure.
I mean, I still don't understand the whole like account migration thing. How does that? I mean, like if you look at some of the interesting accounts that are multi-sig, right? Issuers. Like, are we saying we're changing the issuer public key?
No, I'm not
Oh.
saying that at all. I'm saying you only need to migrate to a new type of account if you want to interact with Jump Cannon. And Cap 49 proposes that exactly, but like to a much greater extent, right? You need to every time you move between the
No, I'm talking about the issuer.
Why would the issuer need to migrate?
Well, they don't want to have like any presence in Jump Cannon. But they would have to use a different account, I guess.
I think like there will need to be a distribution account, potentially, that if they want to interact with smart contracts, they need to be on smart. But I think that depends a lot on the asset interoperability story, which we still need to think about.
Can you just tell me what this migration looks like? Like, I want to migrate from my classic account to a smart account. What has to happen? Do I actually have to like somehow move balances, or does it just like transmute balances and annihilate the classic key?
The very simple happy path for something like this is that you log into your wallet tells you, hey, we have a lot of new functionality on smart contracts, but for that to work, you need to migrate to a new account. Let's call it a D account. It takes you through that process, and once it effectively like merges your account. And I'm saying happy path meaning that there's like just a single signer, and it's the master signer, and then now you have a D account, and you can either operate on regular Stellar Classic, make classic payments and such, or you can operate on smart contracts. But it's a simple account. You can never actually do on-chain multi-sig the way that you did with your previous account.
I don't know if we need to explore necessarily like in this meeting, like this actual migration flow. It sounds like it will have a lot of edge cases. Like I'm thinking like from a KYC point of view, right? Like you have a bunch of trust lines. Like you need those D accounts to have the exact same public key, because that's what got KYC'd. Or you deauthorize trust lines. That's another option. But things like that.
Yeah, again, like the happy path constitutes of accounts that are very simple. They have a single master signer, and assets that are, for the most part, the overwhelming majority are not not auth required, or and can easily be moved.
Cool. Yeah, just that's all I was hoping for, was just a very quick explanation to like help clarify in my mind what it was that we were talking about. Thanks.
John,
I mean,
can you
I
poke
guess
some holes in this thing?
I mean, like, I need to think about it more. I'm like, what I really would need to do is go and like look at what the current like configuration of accounts network wide is. There's like 6.7 million accounts or something like that. Can most people actually just migrate to a new public key? Meaning that like their master weight has weight 1, all their thresholds are equal to 1. If that's the case, or so I said migrate to a new public key, I meant migrate to only their public key. If that is what most accounts are like, then like maybe this is reasonable. If most accounts aren't like that, or even if many accounts aren't like that, then I don't think it actually gets us anything. There's no worth poking holes in it, because it's just like it's not general enough to be worth considering. So I need to go and like hit up Hubble and figure out what the situation is.
Wait, hold on. But isn't the
Also,
alternative that people still can't use Smart, except now they could lose money if people accidentally send them money on Smart? I'd rather have a world where most people can't use Smart than one where most people can't use Smart, but it looks like they can, and so money gets destroyed.
yeah, I also just want to point out, like, we can research this with Hubble, but what we should also evaluate is there may be a lot of accounts on Hubble that are not actually meaningful. And whereas we should also have a look at products that are getting developed, either recently or in the future that we know of that are getting developed on Stellar. Are they using multisig? Are they using things like SEP30? How are those like, what's the story going to be for products that are just setting out now with multisig? Because if we do just have a look at just Hubble, we may find a large number of accounts that only use a master key. They also may be inactive accounts, maybe accounts from the past, accounts that are not actually relevant to where we're going from here.
Yeah, but Lee, like, we're not annihilating the idea of multisig, right? We're just saying that like these we need to find like a different multi-sig construction for these accounts moving to this new account type.
Well, it sounds like on some level, at least, though, doing some research is a good idea to understand how people are using multisig currently, right? Any other thoughts on this issue? I mean, we have about 14 minutes left, and we can stay here or we can move on.
No, I'd like to go back to like the first thing, because maybe that would be a different approach to this problem. That is like the question I was asking earlier. That is, how do we think about like I don't know how this is solved in Ethereum. Like if you have this flexible invoker thing, like if I decide to take my account and move my assets into a smart wallet, my smart wallet becomes my public address in a way. Is it? I think, right? So how does the money get routed if somebody sends funds to my old key?
If you have the address, and sorry, you have the key and only you have the key, you just go grab it.
Public key. No, what I mean is that, well, it's kind of funny, right? Like, does it mean I have to, even though I decided to upgrade my, my setup to a smart wallet, I still have to keep this kind of single key setup around forever?
You didn't upgrade to a smart wallet. You also have a smart wallet. If you
Well,
were using an address, there's no way to stop using that address other than to tell everybody to stop sending money there. Like, I mean, it's no different from when you move houses, right? Like, people will keep sending mail to your old address, much to USPS's dismay, unless you tell them not to.
So you can do forwarding, right? In that case, so that's kind of
like
what
6
I'm getting
months,
to.
but there's no way we're going to do that, probably.
Like no, but like if we had to support those type of scenarios, some way to do forwarding, you could do forwarding for those multi-sig accounts.
Why do forwarding though? Just keep the key around until you don't want to forward anymore and go and collect the money. Like, we don't need to be, we don't need to be dad for these people. If they want to switch to a smart wallet, they should know what they're doing.
No, I'm just trying to kind of compare the complexity of like migrating to those whatever accounts to having a way to kind of make it easy for people to change their keys, basically, and even in smart.
If you make it easy for people to change your keys, you're just going to end up right back at the, okay, well, now I have to go and read this other thing and check the signatures based off of that, and everything becomes less efficient. Like, do we care about performance or not? If we don't care about performance, let's just glue on the EVM and get 13 TPS. I don't understand why we're working so hard. If we care about performance, we can't do that, and we have to do better, but that means we should be making decisions that matter.
I mean, it's not just about performance, right? It's about, like, the whole reason we're talking about this is for usability, right? Like making it that people don't have those foot guns, everywhere.
But I mean, I think that we care not so much about performance in absolute terms as the scalability of performance in terms of cores. So if we can kind of split it up into work that can be parallelized and work that can't be, then as long as there's a way to do the signature checking such that it can be parallelized, I don't care if it's, I'd rather have it be 4 times as expensive but embarrassingly parallel as 4 times faster, and like it's competing for like the same CPU core as like all the other logic and all the transactions.
Sure, but I'd also rather it just be embarrassingly parallel and not 4 times slower. And like, what I'm saying is like, the discussion we're having right now doesn't change the parallelization. Well, it probably makes it a little worse because there'll be more contention. But it definitely doesn't make it better. That's definitely, like, Nico's proposal will not make it better, but it does mean there's more work for everybody to do. So it's definitely going to be slower.
Should we just add BLS signatures? The other thing is, like, do we have a particular, it seems like not all implementations of threshold schnorr, like people like cut some corners, like do things that like we don't know how to attack, but they prevent the proofs from going through. So there's the fact that like the multi-sig we have now is maybe slow, but it is very simple and very easy to understand the security.
And if you want this level of security, you can still use a smart wallet. You just pay for it. And if you trust the threshold schemes, you use the threshold schemes. And if you're happy having a single key, you use a single key. Same thing I said before. Like, I don't need to tell people what to do in a land of smart contracts, because in a land of smart contracts, if they don't like the thing that I told them to do, you know what they're going to do? They're just going to do it slower, differently,
right?
Anyway,
you can make it easy for them to do, right? So you can make it very easy for someone to use in a smart contract to check that something's been authorized by a particular classic account, right? And if that is something that's easy to do, then people will use it where it's appropriate, and there'll be more coherence across the two worlds.
Do we want to talk a bit about contract lifecycle today?
We have like 8 minutes, but I mean there are some open questions that came up during the in the dev mailing list that I can talk about if we think we have enough time. I think.
I think we should start on it, and if we run out of time, we can bring it back up at the next meeting.
Okay. So one of the questions we're still discussing is if the contract code like vector should be fixed, like the size should be fixed in the XDR, or should it be configurable by the validators? And the advantage of having it configurable by the validators is if for some reason we think it's if there's an issue, the validators can if there's like an overlay issue, for example, and fix it through the validators instead of updating the XDR, which would require I believe would require a protocol upgrade. So does anyone have any thoughts on this? I think John's advocating for it to be fixed in the XDR, and Nico is advocating for it to be configurable.
Well, you need a parameter upgrade either way, right? Or are you suggesting that different validators have different thresholds?
No. So So you would need you need either be a parameter upgrade, like an upgrade to the validators, or a protocol upgrade.
Right. So either way, it goes to a consensus. In one, you don't need to recompile. That seems reasonable to not have to recompile, I guess. Or to pick maybe we don't pick like 4 gigabytes, but we pick something that's much larger than we think people should need in the XDR, and then we enforce a lower limit in validators.
Yeah, that's what I was thinking.
I just like my big concern about this is like it's not safe to ever make the number lower. You can only ever make it bigger. And I'm just like, what is the point of this work? Like why shouldn't we just choose a number that makes sense? And basically if people want to write bigger contracts, just split your logic up among 2 contracts. I mean, it's not a big deal. Like, do we really want people uploading single operations to upload like a gigabyte, 100 megabytes, 10 kilo? Like, what's the number that we're happy with people uploading in a single operation? Choose that number and call it a day. Likewise, what's the number that we're happy loading up into the VM as a single operation and call it a day? Graydon, I can see you're talking, but I can't hear you at all. I don't know if anybody else can.
Hey, can you hear me now?
Yeah.
Cool. Yeah, I just wanted to point out we have the same issue basically with like there's going to be quite a lot of fixed numeric parameters in the system. It's really not just one. All of the cost factors, all of the memory limits, all of the parallelization factor when we get to parallel execution. There's going to be a big bucket of numbers that are just constants that the system runs on, and there's going to be this is a cap coming at some point. We haven't got to it yet, but there's going to be a parameters block. We're not going to have a single parameter in the ledger header for every single one of these because the ledger header will get gigantic. We're going to have a new magic ledger entry called smart contract numeric parameters, and people are going to have to vote on that on a regular basis. So I would just say it is a number in there.
But we would have to agree it's a number that can only go up then. Never go down.
No, I don't agree with that at all.
Or it can go down with we just have to have a policy that like we'll give you 2 months notice before we reduce it or something. But
no, I don't agree with that. It cannot go down. You can break somebody's smart contract by making it go down.
Yeah.
Even if you say like I'm still willing to run a smart contract that's longer than this was uploaded before. What if that smart contract itself is a factory which deploys new smart contracts?
No. There's no question that there's going to be parameter changes that will break existing smart contracts. That's guaranteed. Because if we change gas limits at all in any direction, some smart contracts will begin passing that didn't, and that implicitly means some will fail that didn't because they were expecting the other one to pass. There are ways in which you break people's code by changing parameters, guaranteed. There's no way to just make it one-sided. That's not going to work.
I'm not clear on why changing the gas factors would break people's code. Like you could always just run it with more gas, right?
Right, but like it's something that you expect to work on one set of parameters will work differently on another set of parameters.
Sure, that's fine. As long as I can figure out how to still run it, it is fine. But like if you lower the size, fact that you can like fundamentally break never to be recoverable a factory contract.
It's totally recoverable. You just have to convince everyone to raise the number again.
So right, so it's only possible to go up as a consequence without breaking people's code.
No, I completely disagree with your premise. These numbers affect whether. I mean, seriously, suppose your contract relies on you call two contracts in order, and it's really important that the first one fails for some reason because you didn't notice that it fails, but it's part of the semantics of your system working that the first call fails, and we increase a limit now it succeeds. Your system stops working. Like, people can rely on things in the wrong order. There's no fix for that if you want the numbers to only ever go up, right? So like, yeah, sometimes you have to redeploy things. Sometimes you have to change things back if you want to fix them because there's no other way. You've set a specific set of parameters that you've defined as the ones that my thing works in, and if the parameters change, it is possible your thing will break.
I mean, I think it's when it comes to all those like weird parameters, I think they're like, especially when it comes to any kind of limit, I think they will always have, like, you know, when it comes to coming down, right, like from those limits, like if you're close to that limit, yeah, I would say like you may get broken like by some weird tweaks like that. Like if you want to be safe, just play in a much smaller, you know, much further from the limit.
Well, I think it's totally reasonable to expect that something like code size is not going to, like, there's no a priori reason why we're going to start reducing that over time. It's probably the case that would stay the same and go up, and I think it's a reasonable assumption. But it's no different than saying, you know, that your set of pre-signed transactions that, you know, can only have a certain fee that they work under, and they won't work if the base fees increase or something like that. Like, there's ways
Like,
that you
we
can
were
break.
actually concerned about that problem, Graydon.
Yeah.
And we were so concerned about it that nobody wanted to raise the base fee, and we actually did cap 15 fee bump transactions to fix that problem. So like, that's actually like an example that like proves the point that this is a problem.
It will continue to be a problem. There's absolutely no way you can fix this by saying it can only move in one direction. That doesn't fix the problem. So as far as I can tell, you're demanding that we fix a problem that can't be fixed.
I think we need to just set expectations appropriately, right? If we tell people your contract, we promise never to break your smart contracts, it's going to be a problem, right? Because we will end up breaking them, and we'll also end up not innovating in ways that we should have innovated. And so, you know, like, people.
I mean, validators may vote that they're not interested in seeing a particular parameter upgrade. That's fair, right? It's not like us making parameter changes. It's like us collectively, the entire network, right? It's not just SDF making these changes, but if a change happens and all the validators vote for it, the validators could vote to migrate to a new protocol version that turns off smart contracts. You know, there's changes that can be made among the validators that will break existing functionality.
I guess the core of my argument here is there are things that that are like worth promising, that are worth not promising to break. And there are things where it's like completely reasonable to make a promise not to break your stuff. And I think code size is definitely an example where it is completely reasonable to promise not to break people's stuff. You said it yourself, you can't foresee a reason why we would want to make the code size smaller.
Not a really simple one, but I mean, if you give me a couple of minutes, I could probably come up with something. I just don't think I don't think it's likely, but you know, there's a difference between likely and what I think we should be promising. I don't see why that promise. I guess I don't see why that promise is more important than any other promise. There are so many other promises we could be making that are also not reasonable. This is just another one that.
This really feels like we're bike shedding at this point. Like, let's get a thing built, and then like how hard or easy we make it to tweak one number, like that's something we can figure out. It's just not an important thing at this point.
And I think David gets the final word in this meeting because we're out of time. But we'll reconvene next week, and obviously there's still activity happening here on the Stellar Dev Discord and on the mailing list. And so anyone who's watching, obviously feel free to jump in there or to see what the discussion, where it's tending. Anyone in this meeting obviously will also talk on those lists and get back together here next week. but we're out of time for now.